Now we're going to talk about exponential functions and this thing called a growth rate or a decay rate, as the case may be. So let's first talk about the formula for an exponential function. And the formula for an exponential function is right here. It's y equals a times b to the x, where a is an initial value and b represents a growth factor. So that's how much your equation is growing at that exponential rate. So let's first talk about cars. Cars decrease over time. There's this website called Kelley Blue Book that your parents might use to find the value of a car at a certain point in time based on mileage and all the other factors that go into the value of a car. But we're going to make this as simple as possible. We're going to know two things. We're going to know that your car started at the value of $18,000 and it decreases by 20% every year. So if I'm going to write this equation in this form, the y equals ab to the x, I know that a is going to be 18,000. So y is going to be 18,000. What I don't know is what's going in this blank, because that's our b value. And t is your independent variable, just like x is. So what goes in this blank? Well, this blank is representing the growth factor, but your car doesn't appreciate, it depreciates. So you're losing money every year that you own this vehicle on this car if you wanted to sell it back or exchange it for another one. So the way that we figure out our decay rate, or our decay factor in this case, so our quote growth factor, but it's going to be going down, is by taking the percentage, this 20%, and subtracting it from 1. Now, whenever we do this, we have to make sure it's 1 minus, not 20%. So I'm not subtracting 20. I'm subtracting the decimal representation of that percentage. So it's going to be 1 minus 0.20, which is 0.8. So 0.8 is going to go in there. Now I can use this equation to fill in the rest of my table for the various times. So I'm just going to tell you what those answers are to save a little bit of time so this video doesn't last forever. But here are the answers. And we get these just by plugging the respective t value in. So to get this answer, I'm plugging 2 in for t in that equation. Now I'll plug in 3 for t, so I get 9,216. When I plug in 4, I get $7,372.80. Now keep in mind, we are talking about money here, so it is very reasonable for all of our units to be in cents. So we're not going to have 3 decimal places in something like this. We're only going to have 2 because that's what's reasonable for money. But that's how we find that. So this is one formula that you're going to have to know. Another formula that you're going to have to know is right here. And this is talking about compounding interest. Why do you know about compounding interest? Well, when you save money, you put your money into a bank. That bank stores your money and it lends it out to other people. So they're going to pay you back for letting them lend out your money. You're not part of any of those transactions, but you do get a tiny, 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 tiny benefit because the interest rate that you earn on a savings account is actually fairly small. But you still get to earn a little bit of money. So this is the equation that we're going to use to calculate how much money we earned, or rather how much money is in our account after we earned money. So these letters all represent something. So let's talk about what they represent. P represents the principal. That's your initial amount of money. That's all that means. R is your rate as a decimal, not a percentage. Just like on the last problem, we're going to change it into a decimal whenever we actually plug in numbers. N is the number of times per year. And T, that little letter right there, is the time. So we're going to take whatever numbers they give us in a problem, we're going to plug them in into the respective appropriate locations, and then we're going to simplify equations and plug in t values and find other things. All right, just like we do with any other equation that you could come up with. Now, just so you know, when it says number of times per year, that's it. That's explained right here in case you miss it. N is the number of times per year. If it says daily, it's 365 times. If it's monthly, it's 12 times. If it's quarterly, it's 4 times. And if it's yearly or annually, it's 1 time. So you just have to make sure you're reading the problem appropriately. So let's use this equation that we have come up with here, and we're going to use it for this problem right here. So in example 2, we have $2,800 is invested in an account earning 2.8% interest compounded daily. Those are all the things. P, this is 2,800. R is our interest rate, but as a decimal, 2.8% is the same thing as taking your decimal. You have to move it 2 places to the left, so it's 0.028. And then compounded daily is 365, and that's your n value. So now we're going to take all those numbers and plug them into our equation. So f of t is going to equal your principal. We're going to have 1 plus your interest rate, which was 0.028. Don't forget to change that number to that decimal. I've seen people forget and then they get it wrong. Over 365 to the 365t. Now, I can't just leave it like this, because when I look at it like this, well, it's a true sentence, it's a true equation, it doesn't give me enough information. I want to know the information, I want to know the equation, and I want to be able to find the growth rate. And to find the growth rate, I need to figure out what this number is in here. And then I have to apply the 365. So let me show you what I mean. So I really have 2,800, and I can't change the 2,800. 2,800 is what it is. It is that principal amount. You're not really going to touch it unless you're plugging things into an equation to get an output. We're not going to simplify within that particular part of the problem. We do need to simplify what's inside the parentheses, though. I'm just going to tell you what that number is. You're welcome to plug that into a calculator if you don't believe me. But it is this number, 76172. Now, in order to simplify this properly or accurately to give me the number that I need this 365. That can't be there. So I'm going to take that 365 and kind of plug it in and put it inside the parentheses. So this is still true. 2,800, 1.000076172 to the 365t, because when you raise a power to a power, you're multiplying them. So it doesn't actually change anything, it just changes where it is, so that now I can simplify the inside of the parentheses again. And when I do, I get 2,800, and then I get 1.0284 to the t. Now let's make sure I read the instructions, because I didn't read them out loud, but it does say round all coefficients in the function to 4 decimal places, which I have. And then determine the percentage of growth per year. The percentage of growth per year is essentially the growth rate. What is the growth rate? So I need to take this number right here. That number. And I need to figure out, well, first, is it bigger than 1 or less than 1? And in this case, it's bigger than 1, which means this is actually a growth rate, not a decay rate. So the growth rate, when it's greater than 1, is 1 minus the number, which makes this 0.0284. That's as a decimal. If they want it as a percentage, then now we need to turn a decimal into a percentage. And to do that, we're going to take our decimal place and move it to the right 2 spaces. So this is a 2.84% increase per year. And that's the other part of the answer.